Hello, everybody. Nice to see you guys. Thank you so much for joining us. My name is Jad. Very excited for you guys to be here, and I'm very pumped to introduce our next speaker, who's going to be talking about real-time predictive card fraud prevention with AI and ML, powered by MongoDB and Databricks. So joining us from Connecticut, a principal on our industry solutions team, primarily focused in financial services, please welcome Shiv Pullepu.
Well, thank you. Hey, good morning, guys. Can you hear me all right? Good morning. Good morning, everyone. Can you hear me? Okay, awesome. So the benefits of embedding advanced AI into applications can solve a number of business challenges. However, if you do not pick right technology combination, the task can become a very uphill battle, right? It is very challenging. Technology selection is a key for creating a simple, elegant, advanced AI-based solutions. In this session, I'm going to cover how you can actually use MongoDB and Databricks to create intelligent applications, right? And I'm also going to actually showcase card fraud prevention as an example to demonstrate the joint value proposition of both these platforms. And my name is Shiv Pullepu. I'm a principal financial services industry at MongoDB. Before MongoDB, I worked in the banking and financial services industry for almost 20 years. Embedding AI into applications, right? Obviously, it accelerates innovation. You can actually use AI to pivot your data to some kind of a business value. And also, it helps you actually bring these insights faster to your consumers or customers in real time or in the moment. And for this reason, most of these financial service institutions, they're actually becoming data plus AI companies, right? But unfortunately, not everyone is actually able to realize the benefits of AI, like you see on this slide, right? There are reasons for that. I'm going to actually share 3 or 4 reasons why they're not able to get a benefit out of this thing, right? So the first one is data silos is one reason, and also team silos is another one. And most importantly, technology sprawl, or using too many technologies to address a challenge is another a bottleneck in this journey, AI journey. So speaking about data silos, right? Traditionally, not just in financial services, you see a clear separation of duties or domains, right? You have application teams on the one side and analytic teams are on the other side. There's a clear separation, right? There exists. I'm not saying there is something wrong with this, but the problem with this type of environment setup is getting data from these applications to something like a data lake or a central data warehouse takes time. It is not easy, and creating integration points is difficult, which means you may not be able to get a holistic data or a payment data or transaction data in real time or in the moment to a central store like this. And the second challenge is that technical sprawl. Banks are faced with technical sprawl, right? You can see if you work in a bank or a financial institution, this may be something familiar to you. I'm not going to go over this in detail, but on the top you see there are a number of applications, right? And using a different text, right? There are niche technologies, one for Redis, for caching, and so on and so forth. Maybe there is a Hibernate to kind of transform your database object to something your application likes it, or can be bind easily to your application, right? You introduce too many technology solutions to actually address any type of business challenge. This is not good. And also there is an integration challenge. Say, for example, you have a cloud infrastructure alongside your on-prem at the top. Integrating this cloud and on-prem technology toolset is not that easy. This is another challenge. So I'm going to, before actually I share my ideas on how you can address these challenges with MongoDB and Databricks, let me take a second to kind of give you a primer on MongoDB. MongoDB is a developer data platform, distributed in nature, and there are a lot of features which are particularly useful for financial services. I actually called out some of my favorite features, which is like one of that is a document model, which is phenomenal. Like you can actually structure any kind of product structures, like a structured product or a derivatives area, right? When you do not have a predefined structure, it is easy to actually structure that. Likewise, you have other advanced features which makes it very easy for implementing any financial services use cases. On the other side, we have a Databricks. Databricks Lakehouse is an AI platform, which is very simple to use. You'll see that in a second in my demo. And this is built on top of an open source foundation, right? Almost like a MongoDB, and uses open source standards. Like MongoDB, this platform actually is available or runs on different hyperscalers, like I mentioned there, Microsoft Azure, AWS, and Google Cloud. So together, these two platforms, right? On the right, you have a AI platform. On the left, you have MongoDB, which is your developer data platform. You can build amazing applications, right? And take the applications quickly to the market. So together, they can actually provide what I call help create these intelligent applications, right? So why I say that this is a good combination, like there are multiple methods exist to kind of integrate these two environments. One of that is a Spark, Apache Spark. That's my favorite. That I'm going to actually double click into part of my demo. And the second one is batch out function, that you can actually batch out data from MongoDB to a S3 bucket in a 4K format or some other form, which is very useful or friendly to Databricks environment. And Kafka is another option. So now I'm going to talk about how we can actually use these two environments to prevent a fraud. Before I do that, I want to actually give you some context, right? Fraud is very broad in nature, right? And fraud can happen from any channel, right? A mobile or a desktop or maybe a bot attacks or anything, right? So there may be many shapes of forms and shapes of fraud. But today I'm going to cover only card fraud. When I say card fraud, it is applied to both credit and debit card fraud, right? So the reason I picked this use case is like financial services, right? Collectively losing around $30 billion annually, right? And in 2022, the number actually moved up a bit. It's like they lost around $33 billion. There is a very, it's like 15% uptick in the amount of money we lost for fraudsters or bad actors, right? So we clearly see the institutions are struggling to prevent fraud. So then you would ask me like why they're struggling. There are multiple reasons. I already covered two reasons there. The first one is broad and dynamic. Like I said, fraud is a very broad. It actually even starts with your account registration, right? Account login. Some people think that the fraud is just only transaction monitoring, but it actually spread from end to end, like starting with your account enrollment. And it's a dynamic, right? So fraudsters are equally intelligent to us, and they always find a different way to kind of circumvent a solution and find a weakness in the solution to kind of attack the system. So it evolves constantly. And the data silos, like I mentioned previously, because of separation of the domains is one particular reason why there is this issue to kind of get a comprehensive view of fraud data in one central place, which is very much required for preventing fraud. And technical sprawl, like I mentioned previously, financial institutions, too many technologies. One is costly to operate, and two, it is very difficult to actually integrate the systems, right? Luckily, we have MongoDB and Databricks to actually address this problem. Rules-based fraud prevention, you can actually use MongoDB features like a chain streams and aggregation pipeline, and AI ML-based fraud prevention can be done using Databricks that I'm going to show you quickly. As a matter of fact, you can actually bring in your own AI ML platform here and replace that with Databricks here. But I'm going to focus on Databricks today. And also, additionally, you can actually use MongoDB to kind of create this case management type tooling, like a dashboards, and also observability charts and all that. You can actually create those features or dashboards very easily with the MongoDB features. Like for example, chain streams, and there is a charts capability in MongoDB, you can do that very easily. So if you put all these pieces together, right, like the 3 stages of a fraud, and you can actually create an architecture diagram like this. This is a very simple and event-driven real-time fraud detection system. On the left, you have different channels, and on the right-hand side, you have all the legacy systems. And like I tried to actually call out the 3 stages I discussed previously. The first one is a fraud detection using some rules, right, that you can manage on top of MongoDB. And the fraud detection using big data analytics, right? AI ML, you see that on the left-hand bottom panel there. And case management is another component to it. So it actually forms nice event-driven architecture. By the way, the similar architecture can be applied or used across other business use cases. So now the fun part starts. Solution demo. Let me actually, before I actually jump into my solution, I wanted to give you a quick high-level overview, right? So what this solution contains, right? There are 3 main components in the solution, right? The fraud solution, I'm going to demonstrate it here. The first one is a client. Obviously, you need a mobile device or a web device to actually initiate a payment. And the second one is a MongoDB, is your application developer data platform. You create these mobile apps, web apps. And then you have a ML platform here, Databricks, right? So there are 2 important things I want to call out here. There are 2 integration points. The first one is a Spark connector. It's a MongoDB native Spark connector that makes it possible to actually ingest data from MongoDB to Databricks, right? You can actually schedule it to run at a predefined interval, or you can actually constantly run to actually get all the signal data from MongoDB. That's the first one. And the second one is when you have a model on Databricks, when you expose the model as an endpoint for an application consumption, right? That a model can be called out from a Databricks function. That's what I mentioned here. In a REST endpoint, you can actually make that call out. So these are 2 main key integration points if you're building a solution. This is where I would actually request you to focus on. So obviously when you get an observation or assessment back from an AI ML model, you can actually use those inferences and actually activate those inferences on different channels like a mobile and web. That's what that alerts to MongoDB fraud alerts can be done here. So let's look at so let me show you some static screens. I want to actually slowly introduce you to the demo with some using some static screens here. We have a simulated mobile app to kind of demonstrate this thing. When you log into the app, it takes a user ID password, and then you log in, you'll see a landing screen with all these options, and there is a transaction option here, and you can initiate a transaction like a test transaction. And once you initiate a transaction, I have 2 actually paths here. One is a happy path. Say for example, you have initiated a good transaction. What kind of a user experience that an end user would see, right? This is what it demonstrates. And the middle part is what I'm going to show you now, that fraud processor that we did at MongoDB as an example solution. It is actually posted on our GitHub, and I have links to this particular solution in my deck in the last slide. So that processor actually does this magic, whether it's a fraud or not. Let's say if it is a fraudulent transaction, what kind of a user experience that you would expect on the device. For security reasons, you don't show all that particular reasons why login is failed or some other reason. You block out all those reasons, but you provide some user-friendly messages on the device here. Okay, let me go to the demo. Like I said, you actually have this mobile app. You log in, you provide your user ID password, and then and behind the scenes, it actually validates your email address, and if an email address is accurate and the password is good, and it takes you to the landing screen here. In here, you see number of options, right? We don't need to focus on all those. The one option I want to focus is a profile screen, and now when I click on a profile screen, you'll see, the amount of the balance of this particular logged in user, and the number of orders this person placed. What I'm going to do is I'm going to click on the transactions. So to initiate a transaction, I want to do a couple of transactions, right? The first one is a good transaction, and I wanted to pay to this merchant, and I pick the merchant information, and then actually I key in my dollar amount here, like $132 a change. And this is a legitimate transaction. Now this is actually going through the back-end fraud processor, like I said previously, and this is a good transaction. Life is good, and successful. Now let's do another transaction. In this case, we'll put a very big amount, right? Something like $9,000 or something. In this app, actually, we set limits to this particular user. You can actually define user specific rules, number of transaction, dollar amounts, limits. Dollar limit, in this case, the dollar limit is $8,000. But I picked $9,000, and therefore the fraud the processor actually kicked out this transaction because it doesn't meet the rules-based authorization. So now let me take a look at the code behind. So there are two ports, like I said, the Databricks port and the MongoDB. On the MongoDB side, you see this is a collection view. I have a collection for merchants, and we used some test data, and a user authorization rules. So there is another collection here. Like I said previously, a user, a logged in user, right? You can actually define number of transactions that he would allow in a given day, or the transaction limit, or the dollar amount. Like I said, like I showed you previously, the previous transaction I used a bigger amount, like more than 8,000. So that's the reason. And this is a transaction data stream, like the raw transaction data coming in from these channels. That data first lands in the MongoDB. There's a collection to kind of persist that data. So once you have the transaction data, this is an important point. You actually futurize the raw transaction data. You clean up the data and create a futures, and then you store the futures in MongoDB. There is a reason why we store it there. Here, the transaction status, right? Finally, when Databricks AI model, when it does this job, it writes back to MongoDB. So on the Databricks side, we have two workflows. One is for training, like training a model, and we used another workflow for actually streaming. The training workflow contains 3 stages. The stage 1 actually ingested data from MongoDB, because we held a lot of historical data for training, and we used Apache Spark to actually pull the data. And the stage 2, it actually futurizes the data and it creates the futures, and it trains the XGB model that we used in this particular example, using that future data that we have actually created. And the final step is actually XGB model. So here, this is an important point. Like I said, Apache Spark connector, you can actually use to get the data. This is your futurization. Like once you actually futurize your raw transaction data, this is your future table. And we have used Databricks to actually do the futurization and create the futures. And we train this model using this future data. And a part of the data, we used it to actually cross-validate the model. In this case, the XGB model that we used. So once that is done, this is actually training. And you can actually, one cool thing about Databricks is MLOps. You can use the MLOps to actually determine a model accuracy, and actually you can manage the model versions and all that. Here, what you see here is a model accuracy, and also you can actually define at a parameter level a weightage. Like you can give for example, latitude and longitude, you give a better weightage, right? Because that may have a bigger bearing on fraud, right? Because depending on the latitude and longitude, you can actually find if the attack is coming from China or some other countries, right? So based on the accuracy, right, once you have like a different versions of your model, and each model has that particular accuracy level. Say, for example, you want to actually pick a specific model like with 90% accuracy, and I actually pick the model. Like here, the XGB model, we have 3 versions, and you can actually pick and choose like a version that you wanted to deploy to a production. So now the second part is rules-based fraud prevention. Previously, I told you about how you can do that using MongoDB, but in this example, we used Databricks to actually do the rules-based fraud prevention as well to make it simple. And here, it actually ingests or reads the data from that authorization collection I showed you previously, all the user-defined variables, and it uses that to actually determine whether it is a fraudulent transaction or not, based on the rules. And once you're good with this particular model, right, you can actually stage this model for productionization, and that's what I'm going to show you now. And again, this is a future view on MongoDB side. So now I picked this model because I like this model. This is the version I wanted to deploy to prod. So version 1 is the one I wanted to pick, and you can pick and choose, and then you can actually go to model deployment interface. And here you can actually deploy this model, right? So once you have actually a deployed model, the cool thing about Databricks is that you can actually test this model in the console itself by providing some test data, test payload. So that's what I'm doing here. I provided some payload to make sure that the model works. The prediction is 1. In this case, 1 means it is a fraudulent transaction. And you could actually do this testing on a Postman as well. That's what I wanted to show here. Similar testing can be done on Postman. You can actually put a test payload before you actually integrate this endpoint in your application. So now the second workflow we have is a streaming workflow, right? So now we have a model endpoint, and streaming this is a continuous streaming from MongoDB. As I said, the transaction first lands in MongoDB. When it lands in MongoDB, so this is Spark connector sitting on Databricks continuously listen to all incoming transactions, and it does its job, and it runs through this model, and it gives whether it's a good or bad, like a yes or no, right? Inference back to writes back to MongoDB. So here's the demo. This is how does it look in action, right? These are 2 workflows, right? So this is a streaming dashboard. This shows like the data as you stream from a MongoDB using the Apache Spark. You can see that the streaming a chart here continuously, right? And you can monitor that in live manner. So now let's go back to Atlas and create a sample transaction. Before I do that, I want to clean up all these collections, right? I want to delete all the existing data here. I cleared up all the transaction status, and I cleared up all data stream, raw data stream, and everything. Once the cleanup is done, I used a test endpoint to actually ingest data into MongoDB. When you actually use this Postman to write some sample data into MongoDB, let's see, it's talking about like what kind of a payload that it attributes in a payload. That's not so important. So this is sending data to MongoDB, and if I refresh the screen, you should see, yeah, boom, like you see the transaction I sent from Postman to Atlas. So this is where you see this continuous streaming dashboard, right? And also now you can see the fraud status and also a transaction status, and the primary key here is a transaction ID, and the future data, right? Future data is actually, futures are extracted on the Databricks side, but Apache Spark writes back to MongoDB. There is a reason why we actually copied all those futures into MongoDB. And this is another important integration point, like I mentioned in the sequence diagram I showed you previously. This is how simple it is to actually integrate Databricks with MongoDB. Inline code, like a line number 10, you can see you're actually making an external call out to Databricks to actually kind of classify whether the transaction is a fraud or not. So in summary, right, this is a code I read recently. I really like this. Especially banks are becoming a museums of technology. I actually attest to that observation, his quote. There are multiple issues, right? The technology spiral is a big one, and data silos, and the departmental silos, and these actually make it very difficult to create any type of intelligent applications, right? Because it makes it very difficult to kind of bring AI into your applications. Like I said, using technology selection is a key thing. Not every software works. Like they say everything works, but like there are only few software that really works in real world. So picking the right technology is a key, right? So you don't need to have like too many technologies to solve a problem like a fraud. You just need two technologies. You can use the two technologies to solve a fraud, like I showed you. I demonstrated you in this deck. Use MongoDB for building amazing applications, and use MongoDB native connectors to bring in AI ML power. Like I said, especially Databricks using the Apache Spark connector. I have some resource links here. We have a financial service hub. Not just this use case, we have a number of use cases for MongoDB. If you are interested in understanding like what MongoDB has to offer in both in the capital markets, retail and commercial banking side, you can actually go follow our link, please. On this solution, I know actually I ran very fast for the benefit of time. We have a dedicated wiki page on this, and also GitHub. In GitHub, we have a step-by-step instructions on how to set up this tool on your local environment. Right, it's very easy to set it up. And one caution, this tool is not production ready. This is just an example tool. Don't expect to run and test it and move it to production the day you actually download it. So just for only demonstration sake only. I wrote a blog on this particular topic, card fraud, and I talked about like in general why it is a big challenge. More on that you can find it here, and we have other resource links here. Thank you so much, guys. Thanks for your time.